So sketch the curve with the equation y equals k minus 1 over 2x, where k is a positive constant. State in terms of k the coordinates of any points of intersection with the coordinate axes and the equation of the horizontal asymptote.
I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. We normally take questions which students find difficult. The idea is to make them understand the basic concepts and look into strategies which can help solve such questions. In this playlist, we are preparing our student for the final exams at Edexcel Level A. The questions are being shared by my student Amy. I hope their solution will help all. We'll begin with discussion on the question and then I'm going to provide you with complete solution. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. This question has been shared by my student Amy. Let us now see how do we solve such questions and get ready for the exam. We need to sketch the curve with the equation y equals to k minus 1 over 2x, where k is a positive constant, right? So k is a positive constant. State in terms of k the coordinates of any points of intersection with coordinate x's. That means x and y intercepts, and the equation of horizontal asymptote. So that is part A. And then the straight line L has equation y equals to 2x plus 3. Given that L cuts the curve in two distinct places, find the range of values of k, writing your answer in set notation. So these are two parts of this question. I'd like you to pause the video, answer these questions, and then look into my suggestions. Let us begin from the first part where we need to figure out two things. One is the horizontal asymptote and the other is intersection with the coordinate axis. So let us see how do we do that. So we are given this equation which is y equals to k minus 1 over 2x. We are also given that k is positive. Now to find the intercepts, we know very clearly that x is not equal to 0, right? And that indicates that there is no y-intercept, right? But we could have x-intercept. So now, let's figure out what is the x-intercept. To find the x-intercept, we'll substitute y equals to 0. So we have 0 equals to k minus 1 over 2x. So we can say 1 over 2x equals to k. And we can cross multiply and we can say 1 over 2k equals to x. So we have the x-intercept which is at 1 over 2k 0, right? So that is the x-intercept. So this is one part of the question. The other part is to find the horizontal asymptote. So what is horizontal asymptote? Let's look into that part. So to find horizontal asymptote, you should find what happens when x is very large, positive infinity, or when x is very large, negative infinity. So in that case, we know very clearly that 1 over 2 of x approaches 0 as x approaches plus or minus infinity, right? And that clearly indicates that y approaches k. And so we have a horizontal asymptote, which is y equals to k. Correct? So that is how you can find the horizontal asymptote. So we have the two values, the intercepts, which are at 1 over 2k, 0, the x-intercept, and we have the horizontal asymptote. Now, we can sketch the curve taking some positive value of k, right? Now, this is minus 1 over 2x. So, if you sketch the curve, how will it look like? So, let me just make a small curve here, right? So in that case, if k is positive, we have a horizontal asymptote, which is y equals to k, right? Now, since it is k minus 1 over 2x, if I take a positive value of k, then the graph will be below k, correct? And for negative value, it is going to be above. And therefore, we do expect the graph, which will be kind of like this. Where clearly the x-intercept, which we just found, will be 1 over 2k. You get the idea. So that is how we could sketch the graph. Is that clear to you? So that becomes the solution for part A. I hope it is absolutely clear. Now let's look into part B, in which we're talking about a line L, which is given by the equation y equals to 2x plus 3. And it cuts the curve y equals to k minus 1 over 2x in two distinct places. Find the range of k. Now, how should we do this particular part? Well, let's look into the diagram once again. So I'm just sketching this to understand the situation. Right, so the value of k we are saying is greater than 0. So it is kind of like this. And we just sketch the graphs, which are kind of like this. Now, we are talking about a line which is y equals to 2x plus 3. So y equals to 2x plus 3 will have y-intercept at 3, right? So, and we want this to have two distinct places where it cuts the graph. Clear? Now, what could be the possible values of k? Now, you could think like this, that if I have a line, let us say the slope is 2, right? So the line could be something like this, where this particular point is 3. That is the line. So in this situation where I have drawn this curve, you see that the line does not intersect the graph, right? Now, you could have different values of k, and that could make sure that the graph does intersect. So the situations could be, as you can see, many different situations, right? You could have a graph going like this or like this, correct? Well, that really depends on the k value. If k is bigger, a larger value, in that case, the graph shifts upwards and it could intersect, right? So the condition which I've drawn here is showing no intersection, but we want it to have two distinct places, right? So in that case, what are we looking for? We're looking for a situation which could be, let me just sketch here, that we have this horizontal line going, which is, I mean, the line, given line going through 3, right? So this is the given line. However, if the value of k is slightly bigger, let us say that the value of k is kind of like this. In that case, it is possible that we might intersect the lower graph, right? Or if the k value is very low, we might intersect the upper graph. You get the idea. Or the k value could be kind of like this. So if it is very low, in that case, the graph could intersect, right? So we could have something like this. Do you see that? Or we could have a situation where the graph could intersect this portion, right? So if k is very large, we could have this portion cutting the graph, right? You get this. If this is pushed up, it could also cross the line at two places. So you're getting the idea, right? Now, whatever the situation is, how do we find these two values of k? So there are a couple of ways. We could equate these two, y equals to 2x plus 3, and solve for 2x plus 3 equals to k minus 1 over 2x. Now in that case, we'll get a quadratic equation. And we know the solution of quadratic equation can be 2 if b square minus 4ac is positive. So let's do it like that. So in that case, if I multiply everything by 2x, it could be written as 4x squared plus 3 times 2x equals to k times 2x minus 1. Now bringing all the terms together, we could write 4x squared plus 6x, and this is minus 2kx plus 1 equals to 0. Now in this quadratic equation, we are looking for bx plus b square minus 4ac, right? So if I take x common, I could write this equation as 4x squared plus x is common, right? So in that case, we have 6x, 6 minus 2k, and taking x as common here, plus 1 equals to 0. Now in this quadratic equation, we are talking about two distinct roots, right? That means b square minus 4ac is greater than 0. Now b is 6 minus 2k. So we can say that 6 minus 2k, that is squared, minus 4 times a, which is 4, and c is 1. That should be greater than 0. So we can now expand this and find our solution, right? So we get 6 minus 2k is greater than taking 16 on the other side. So this is whole square. So square, if I do square root, that means absolute value of 6 minus 2k is actually greater than square root of 16, which is 4, right? So that gives you two solutions. One is that 6 minus 2k is less than minus 4. And the other is 6 minus 2k is greater than 4. So we get 2k, 6 plus 4 is less than 2k, or 10 divided by 2 is less than 4, or k is greater than 5, right? On the other hand, we get 6 minus 4 is greater than 2k, or 2 is greater than 2k, or 1 is greater than k. So do you see, we have two different conditions here. So the condition is that k is between 1 and 5. You get the idea? So that gives us that k is either less than 1, right? So 1 is greater than k means k is less than 1. So that gives us two solutions, which is k is 1 is greater than k means k is less than 1. And the other one is k is greater than 5. So these are the two conditions when we have two distinct points where the line will cut the rational function given by k minus 1 over 2x. You get the idea. Now we already given the condition that k is positive. So we also know that k is less than 1, but k is greater than 0, right? So because we know that k is positive, you get the idea. So let me rewrite the solution here. One of the solution is that k is greater than 0 and less than 1, and the other is that k could be greater than 5. So under these two conditions, we'll have two distinct point of intersections in the given scenario. So that is one way of doing it, straightforward. Now, can you think about another process of finding the same answer? So we're talking about alternate method. So let's now look into alternate method. We are going to use derivatives. Since in Edexcel level A, you have learned derivatives and we could use that. Now the concept here is that we have the line which is given to us as y equals to 2x plus 3. So the gradient is 2. So that really means that if the line cuts the graph at one point, it is tangential, right? So let's just sketch the graph once again. And let us assume that for some value, we have this graph and that is the graph, right? So let's take a situation where the line is tangential, right? So let's think about this line being tangential to the graph. So let us say we have a situation where the line is tangent to the graph, that is the line L. And we can find that what is this value of x at which it is tangent. Now, if k is more than that, then there are 2 points of intersection, otherwise 1. And we could do this for both the lines. You get the idea? So we are finding the point on the graph where the gradient is 2. Then it will have 1 point of intersection. So we have the value which is y equals to k minus 1 over 2x. So what is derivative? 0 minus. So this is 1 over x squared with a negative sign. So that gives you positive half 1 over x squared, right? So let me write it. Positive 1 over 2x squared. Is that clear to you? So that becomes the derivative for the given function. And we want this to be 2. So this can be 2 when x is equal to what? So let's solve for it. So we have 1 over 4 equals to x squared, and that gives you x as equal to plus minus half. So we get the value of x as plus and minus half. So this value of x could be minus half. You get the idea. Now, if this is minus half, what is the y value? Let's figure this out. So y equals 2. We can calculate for both, right? Plus or minus half, right? So at this value, what is the y value? That is what we'll figure out. So if x is plus or minus half, let's write plus or minus half. Plus 3. We get what? We get plus or minus 1 plus 3. So the y value could be either 4 or it could be 2. So these are the 2 points of intersection, correct? So y value for x equals to half is 4, and for minus half it is 2. Now we can find the k values. Do you see that? So what could be the k values? So within this interval, we do not have 2 distinct points, right? But beyond this, we have 2 distinct points. So let's now solve the equation y equals to k minus 1 over 2x. Substituting half and 4, we get 4 equals to k minus 2 times 1 over 2. So that gives you k minus 1, or the value of k is equal to 4 plus 1, which is 5. You get 1 point. Do you see that? Now similarly, when I place the y value as 2 and x as minus half, I get the other answer, right? So we get y equals to k. Now if I substitute minus half, this will be plus 1, and so the y value will be 2. And that gives me k equals to 2 minus 1, which is 1. Do you see that? So again, we are getting that this region in between, where there is either one point of intersection or no point of intersection, is between 1 and 5. So we know that k is, we know it is greater than 0, but less than 1, or k is greater than 5. Do you see that? So we do get our result from this type of calculation. So you understand the concept, right? So what we figure out in this particular case is that, let me summarize this strategy. Very neat strategy. So we are saying that these are the two situations in which case we get the k value as equal to 5 or equals to 1. So in this, for these k values, we have 0 or no point of intersection. You get the idea. So we figure out that tangent, that y equals to 2x plus 3 is tangent to y equals to k minus 1 over 2x at the point half 4 and minus half 2. Do you understand? So for these values, k is 1 and 5 respectively. You get the idea. And therefore, the value of k is not between this interval, right? So either it is less than 1 or it is greater than 5. We are given k is positive, so it has to be greater than 0. Also, that was given in part A. So I hope you understand how do we solve this particular question. So we have solved part B using alternate method, right? It is important to understand what strategies we could adopt to solve our problems. And I hope these two methods which we used, one using the discriminant the other using derivatives, will give you a stronger foundation to be prepared for such exams. I hope it makes sense. Feel free to write a comment, share your views, and if you really like my videos, that'd be great. You can subscribe to my videos and also learn from me by sending an email on the address given. Thank you and all the best.